Okay, so welcome back, and so we're going to do an example of where we're going to use linear models to represent cost, revenue, and profit for this situation. So what do we have? We have the cost to produce an item is a linear model, so we're assuming it's a linear model and all items produced are sold. Okay, and so we're also given that the fixed cost is $1,500. And the variable cost, or the marginal cost, per item is $100. So the cost to produce each item that they're selling is $100 per item. And the item sells for $125. So we want to write a linear function that represents or models the following situations, the following. So the first one is cost. Okay, so cost is going to be, remember, it's going to be the AX plus B, right? So it's going to be, this is the variable cost, right? This is the variable cost. It's attached to X, right? It's per item. And this is the fixed cost. So our answer is going to be what? Well, what's the variable cost? The variable cost is $100 per item, so it's going to be A is 100. And then the fixed cost is $1,500. And so that's our answer. Okay. Now revenue. Revenue is based on how many you're selling, right? And what the price is for each one. So revenue is money coming in. So think of cost as money going out. That's this. Revenue, money coming in. So how does that? It's based on the price and how many we sell, right? So revenue then would be this function. R of X equals, well, what's the price? It's $125 per item, right? And so remember, R of X is equal to the price times the number of widgets sold. So price is 125 and times X. X is the number of widgets sold. So this is our revenue function. Okay, now profit. Now profit, remember, is the difference between revenue and cost. So money coming in minus money going out. So in this case here, oops, let me do it this way. We're going to have profit equals revenue minus cost. And so that's what we're going to end up with. Okay? So now what I'm going to do is I'm going to take these two and I'm going to stick them in there. So what do we get? We get profit. And we're going to stick the revenue. So revenue is 125 times X minus the cost function, which we have as a 100X plus 15. Okay. 1,500. And so now notice how I'm subtracting the entire cost function. Okay. So now I'm going to distribute, and I get 125x minus 100x minus 1,500. And so now our final profit function becomes P of x is equal to, well, I'm going to combine like terms, so this is going to give me 25x minus 1,500. And so that is our profit function. Okay. Now, if we have the profit function, right, another way to find the break-even point, if I wanted to find out, hey, how many do I need to sell in order to break even? Well, I could just set this function equal to 0 and solve it. Okay. Or if I wanted to find out, hey, how many widgets or do I need to sell in order to make sure that I have a positive profit, you know? So I could set this to an inequality and solve the inequality for profit greater than 0. So again, either way, okay? So that's it. So those are the answers. And yeah, let me know if you have any questions.